Okay, so um, thank you for coming and thank you for organizing the conference. This has been really interesting. My name is Joaqui Atria, and I'm here to talk about HTTP cookies. Um, the slides for this presentation are available on this URL, which I'll copy in the chat, um, just in case you want to follow along. Um, So I wrote, I've written a couple of Raku distributions, but I think the one that I at least see as the most successful and the one that seems to have the most use is a port of the Perl HTTP Tiny distribution, which I released a couple of years ago, and we use for the Rakuland website itself. So in that sense, we're dogfooding that, and I'm pretty happy with how it's turned out. Some of the things that it can do is well, it's a fully HTTP1 compliant library. It has no dependencies, and it support other than the fact that some of the functionality depends on optional libraries, like for example HTTPS support. It supports both HTTP and HTTPS proxies, streaming requests and responses, all types of like form uploads, range requests. It was a lot of fun to work on it. I learned a lot, and I think it really filled a niche that, at least in my experience, was missing. So I'm pretty happy with how it turned out. But it doesn't do some things, and these and some other items have been on the to-do list from the very beginning. Timeouts are missing because of some limitations with the handles that it uses on the under the hood, and cookie support was missing too, but not anymore. Since version 0.2, it supports cookies, and I wanted to talk a little bit about how that came to be. Very briefly, just in case. Now, I've been thinking about HTTP cookies quite a bit while working on this, but I know that not everybody has had the pleasure of reading the RFC. So just a very quick cookie primer. The core idea of HTTP cookies is that they're a way for the server to store state in the client. It's a simple idea, but it has all sorts of ramifications. The shape is very simple. It's just a key value pair with a bunch of attributes, and they're sent by the server in a header, set cookie header with the key and the value, and then all of these attributes. And the attributes are there mainly to govern what the scope of the cookie should be, what it should apply to. There's attributes. These attributes are specified in the spec itself, and there's ways for new attributes to be added, and some of them have. Some of the ones that have been sort of established are secure and HTTP only, that define whether something, what is the protocol that the cookies applies for. There's domain and path, which specify the scope, so which domains and subdomains and which paths within those domains and subdomains it applies for. And then you have expires and max age that determine what the lifespan of the cookie is. In response to a question in chat, yes, I am the author of HTTP Tiny. Well, the Raku version, not the Perl version. So then, using these attributes, the client determines what cookie is applicable for a request, and then sends it back to the server in this cookie header. they've been used for a long time. They started being used experimentally in 1994, and since then they've been there's been several RFCs that have sort of specified different versions of cookies. The one that is active now dates back from 2011, RFC 6265. But there's a next version which is being drafted and has seen a number of revisions. I think the latest version, the latest revision is like 11. So it's very likely that a new version is going to be published soon, and that one will include some features that are currently in use. So, for example, it will define what the same side attribute behaves like, which is currently unspec. But currently 6265 is the one that is current. That is the one that is active, and that's the one that we're I'm ultimately targeting. So domains and paths are interesting because you have there's some risks involved. So you have the domain can be any domain, and of course it can be subdomains, and then paths can be any path within those domains and subdomains. So for example, if you have these cookies here, and these are requests. So for example, with a request to the root in example.com, you would only get cookie A because cookie B applies to foo, so it doesn't apply to root. And these two apply to sub.example.com. If you called sub.example.com/foo, then all of these cookies apply because they either apply to a domain, the domain of the request, or a domain that is at a higher level, and to the path or to a path that is at a higher level. So there's all these rules that specify which requests should get which cookies. The rules are not quite the same for what responses can set which cookies. So for example, with the same set of cookies, this cookie C that applies to a subdomain cannot be set if the response is being received from the top level example.com. Paths are ignored in this case. But this is the sort of thing that that can start getting tricky, in particular because there's this thing called super cookies, which is, if we go back to this slide, example.com applies to everything under example.com, or a cookie whose domain is example.com applies to sub.example.com and bar.example.com, etc. So there's nothing stopping you technically from just setting the domain to say com, and that should apply to amazon.com and any site under .com. These are called super cookies, and it's basically when the domain of a cookie is a top level domain. But of course that raises, before that, so with that caveat out of the way, this is sort of, the next step of actually adding cookie support. So the goals of this project were that it could be something that I could use with HTTP Tiny, of course. If I cannot use it with HTTP Tiny, then it's hardly adding support in HTTP Tiny. And the other thing is that it needed to be compliant with RFC 6265. So I wanted something to be, HTTP Tiny aims to be small but fully compliant, and I wanted something that would allow the same sort of, principle. So I took a look at some of the prior art in the Raku ecosystem. And there's actually two cookie jars. So here we're thinking about the library that would make that decision, right? That would store the cookie state and then make the decision of, given a request, is this cookie applicable or not? There's two, HTTP cookies, which seems to be a port of a Perl library, and Crow HTTP client cookie jar. But both of these had issues that made them unattractive from my perspective. well, the fact that there was a limited choice was, it's kind of neither here nor there, but it did put me in a tight position because both of these are actually distributed with an HTTP client. So if the point here is to have a cookie jar that you can use with HTTP Tiny, which is supposed to be a user agent without dependencies, then if in order to do that, you need to install another user agent, then it seems a little pointless. Another issue with that is that because they are distributed with these user agents, they rely on those frameworks. So they really buy into it. They use HTTP, the HTTP the one that ships with HTTP user agent will use the HTTP messages and responses, response objects. The one that ships with CRO will use, CRO objects to represent URIs and requests and responses and cookies. So it's hard to use them outside of those frameworks. They were also missing some parts of the spec. This is something that affects HTTP cookies more heavily than the one that ships with CRO. But both of them were also missing this way to protect them, to protect the user against super cookies, which is something that I was interested in protecting against. And this led to a distribution called Cookie Jar, which was released a couple of months ago, which is basically a minimalist HTTP cookie jar, which is complying with RFC 6265. It is largely inspired from the code in HTTP cookie jar, the Perl library. It does have one dependency on IDNA Punycode to support international domains, but it has no other functional dependencies. So by that, I mean that you can use this without buying into anything. You can use it just with plain strings. But then, what about super cookies? We said super cookies are these cookies that have domains that are top-level domains. And then the question is, of course, well, what is a top-level domain? And some of them are pretty easy, .com, .org, .net, sure. Then you start getting into, like .pizza. So it's not like you can have a short list of words to match. And you also have top-level domains that are combined, .co.uk. And some of them can be combined several levels deep, like .pvt.k12.ma.us. I'm not going to get into the discussion about what sort of who decides what how close to the top a domain needs to be a top-level domain, because luckily for us, that answer has been that question has been answered by a thing called the PublicSuffix list, which is a project that was initially started by Mozilla. It's available online. It's used very widely, and it's maintained by community volunteers who are constantly keeping an eye on what new top-level domains appear. And it lists top-level domains, and this is a little strange. It lists both the ICANN registered ones, so for example, .uk or .com, and it also lists domains that belong to sort of sufficiently large corporations, let's say. So Amazon.com is in that, because for all intents and purposes, it behaves like a top-level domain. So in order to protect against super cookies, you need access to the PublicSuffix list. Sadly, when I looked for prior art in the ecosystem, I found nothing, which explains why none of these other cookie jars support it. So I started looking into how that could be done. And actually, there's three types of entries in the PublicSuffix list. There's like literal top-level domains. There's like patterns that apply to several, like top-level things that look like categories of top-level domains. And then there's exceptions to those patterns. So actually parsing it is not that hard, and using it is not that hard. But I bumped into another problem, which was that this is a list that is constantly getting updated, sometimes several times a week. And I cannot commit to keeping an eye on the public suffix list to keep it up to date. So then I was faced with a question: what do? Do I curate updates? So, for example, do I take a look at the public suffix list releases in the last month and decide whether it makes sense to update or not? I could allow users to update it. So I think that's the method that some of the Perl libraries use, for example, that you can say use, something public list and then give it a list, and that's something that I considered doing. But the other alternative, which I got from the idea I got from a Rust library, which is that it basically keeps a track of the updates. Every time there is an update, it automatically mints a new release, and that gets shipped to the ecosystem, which is ultimately the method that I ended up using. And so you know where this is going. This resulted in a new distribution, PublicSuffix, that was released very soon after cookie jar, which is basically a distribution that allows, it does one thing. It parses the cookie, the public suffix list. It stores it on compilation, and it gets automatically updated whenever there's a new version of the public suffix list. Whether this is the right method, whether this is support for the user providing a public suffix list should be added or not, I'm not set against it. So if there's a use case for that, this could definitely be added. But I liked the fact that if I ship with my own list, then it means that I can parse it once on compilation and just leave it at that. It should make it very fast, although I've never benchmarked it. So now we're several levels deep, right? So let's try to get back to the surface. So the public suffix module, you can use it on its own. Use public suffix, and then it exports to functions, public suffix, which will take a host and give you either a public suffix or just the type, the string type object. And it takes both a punycode and not punycoded URLs, and it tries to return what you gave it. So if you gave it a unicoded host, it will try to give you the unicoded version. And also it exports a registrable domain, which is it's basically the top level domain plus the highest subdomain that is not the public level domain. So in this case, land is the top level domain, and the registrable domain is Raku land. And you can use that automatically. So as long as that module is installed, cookie jar will know how to use it. And you can use cookie jar like it's in this slide. So you use cookie jar, and you can add them with the URL that issued the response plus the actual value from the set cookie header, and you'll know how to do it. It will know to parse them and whether the specific response is allowed to set that cookie. You can get the read-only cookies if you want to do some additional processing, or you can just get the header for a specific request, both with a method and a URL, and then it'll just generate the header for it. And you can use it with HTTP Tiny, like I said, since version 0.2. You construct it yourself, and then you pass it as an argument to the constructor. It doesn't check internally that it needs to be this particular class. As long as the cookie jar that you pass follows, provides these methods with these signatures, then HTTP Tiny is happy to use whatever you give it. And that's about it. There's a couple of things that I thought while working on this. I thought I was being clever, but I heard somebody else say it recently, so I don't think this is my idea. But Raku is both a young language, but a language that has had a really long youth. So you can tell that because when you start trying to use it in earnest, you often bump into issues where there's holes that in surprising places. So, for example, I did not expect to find that there was no support existing for public suffixes. I did not expect to have to get that low level in order to implement this. But fortunately, you know, Raku does offer you the tools to fill in those holes. And experiences like this, where we try to solve a hard problem and we try to do it in earnest, and we bump into a hole and we fill it in, that's going to ultimately help us all. It's also difficult to find the right tools for the job and to evaluate what tools are the right ones. So I had to do quite a bit of investigation to tell, for example, whether the cookie jars that are available are good for purpose. And I don't know if, you know, there may be other cookie jars that I couldn't find. So so yeah, I thought a lot about this particular slide when listening to Leon's talk. I think the ecosystem is good. There's plenty of good in there, but there's also a lot of stuff that we need to curate. And building the tools that allow us to find the real gems in that ecosystem is going to be hard work, but very valuable. And that's it. Thank you, everyone. I will be happy to take questions. Anton?
Hello, nice talk. I mean, nice overview. So I would like to comment, since I think one of your comments to the previous talk was that you come from academic background, but you haven't used data science or something like that, right? I'm paraphrasing. The way you refactored PublicSuffix, this is a typical application of making data packages. I strongly advise people who do data science and machine learning to separate the data from the actual, you know, logic functionalities. It's no brainer for most people in this community, but you know, it's yeah, I mean, teaching data scientists software engineering type of thinking, it is a little bit of a challenge, and this is one of the things I'm saying. And so make data packages, and I think this is basically an example of a good data package, you know, which is being used by something else in Raku.
Thank you. Yeah, I wasn't actually very confident about the way that I chose to go here. When I first found that Rust library that was automatically minting releases, I'm like, this is madness. We should never have used computers in the first place. But it turned out to be not such a bad idea in the end. It does mean that I don't know. It seemed in the end, it seemed like a good idea. I did debate whether I should also make a talk about how I ended up implementing those automatic releases, because that was a challenge on its own. But I haven't. I mean, currently it's just a cron job in my computer, so it's not a very clean solution. There's been some conversation about using some of the distributions that have started appearing more recently, like I think Tomtit was a good possibility, or Sparky. A lot of the work by Melagic is very good and might be useful for that. But when I have a good solution for that, I might make another talk about it.
Yeah, thank you.
Yeah, JJ, doing the automated like cron job is a little better than what I have with my time zones one. I just wait for the email from IANA, and then I have a little script in my tools directory of the module, and I click update, double check everything, and then submit it. But thankfully mine are only a couple times a year. They're not like weekly, like it sounds like this one is. But what I have found is it's a little tricky about it is even when you update them, I think I'm not 100% sure how it works on the module installation, but my impression is that if a module is compiled using one of these and then you update the module, that one that compiled against it won't all of a sudden get access to the new data. At least that's my understanding of it, which can complicate how, as you push out updates, if a program's using this and then stuff gets updated, that module won't all of a sudden see the new data. I don't think there's anything we can do as module authors there, providing this source, but I think that might be something to think about, how we could, maybe have Zeph sort of auto update or auto recompile, but I'm not sure what the best solution there is, but it is something to, I guess, take into consideration.
Yeah, I think it's bumping into these sort of problems that will probably help us find the right answers to those questions. I don't think, I at least had never really thought about this particular type of problem, or how this particular type of solution interacts with what you were talking about. For example, like other modules that use this that have already been compiled, that don't know that they need to be recompiled. It might be that is a good argument against this particular type of solution. I'm not sure, but I guess as long as we're thinking about it, time will tell. Liz?
Sorry. Yeah. The thing is, if you pin your version in your own code, you will keep that version. If you don't pin your own version in your own code, then whenever you update it with Zeph, you'll get a new version. It's up to the user, really.
Yeah. This is true. Patrick, I think you had a question before this, actually.
Yeah. I think you have put quite a lot of thought into this. Can you elaborate a bit on why you think automatic updates would be a bad idea for this? Like having a module that pulls the suffix list on first use and then does it like on every use every 2 days or something like that?
So
you wouldn't have the box that we are currently depending on your cron job box.
This is true.
I don't like that idea.
So it's possible. So one of the alternatives that I thought was, if you use PublicSuffix and then give it like the path to a file, it will just read that file, whatever it is. And that would solve the problem that you have, or the problem that you are thinking about. As long as if my cron job breaks, knock on wood, you can still update that file and you'll get the right version. Like I said, I'm not opposed to this solution. I just went with this one in the meantime. Maybe I was enthused by the strangeness of the problem. But I'm not opposed to being able to give it a list to read. Vadim?
Basically, part of my suggestion has been resolved already, but just to sum up a little bit, usually when I see a problem like that, where I don't know how to solve something, it might be a good idea to leave this solution up to the user. Just provide him with a set of options, whether he pull in a precompiled module with more static data, or if they can fetch data pack from somewhere prepared one, or it could be done locally on a schedule they would like the schedule to be, whether it's each start or maybe, just give it a method that kicks in and starts the process of updating the public list, so that a user can decide when it's best for them to update the list. Having an option solves a lot of problems. When you have a choice, you decide what's best for you. But that's, just a suggestion, and I don't think it's worth really discussing. Whatever. The thing which I really think of is more important is that You mentioned we have a couple of different clients already. We have at least 2 implementations of cookie jars, and they are very compatible. Maybe it's time to think about standardizing this kind of interfaces. Like we already have a role for HTTP client. I don't remember what the module is, but it's what it is. It's a role which defines standards for HTTP implementations. So maybe it's worth considering adding a module like that for cookie jars and for cookie handling. So that there is a role which is said that it provides all the interfaces any client, any server may use.
So on the first question, what I thought was amusing was that this was my way of basically leaving it up to the user. You know, the use, like you said, the user should be the one that decides what schedule this gets updated, and basically I'm allowing for that. You know, the user gets to decide when they use Zeph upgrade or Zeph install. They get to choose basically. I understand that, like, you know, we kind of like fall on different sides of like where the user lives there and what kind of decisions they're making. But like, I find it amusing that I was using the same sort of guideline as you, and I ended up in a different solution. But yeah, I mean, like that can be discussed sort of in more detail later. As for the second question, yes, we do have. I would love for there to be a standard interface for this sort of thing. It would definitely make my job easier because HTTP Tiny, like I said, checks whether the interface matches something. The thing is, like I said, you know, there's these 2 cookie jars that exist already. Both of these have very different interfaces. I mean, like they sort of allow the same sort of thing, but the methods are named different. They take different types of arguments. They work differently. So there was nothing for me to sort of like hold on to. So it's like that XKCD comic where, you know, there's 11 competing standards. We should have 1, and now we have 12. So now we have 3 different interfaces for cookie jars. I would be super on board with the idea of creating a sort of, you know, interface that can be shared among other implementations. And if there's people interested in that, I'll be happy to talk about it. It does look like we're running out of time, but if I am on IRC and on Twitter and on a bunch of other places, so if people want to talk to me, I should be easy to find. And thank you, everyone.